I think we should be good. One more time, welcome everyone to Cloud Data Driven Online User Group Meeting. And we are about to get started. If you have not been part of our data-driven community, we highly suggest you to go and scan this QR code, access to our website, register for save your spot, I would say. Okay. And we also have featured data driven, and featured data driven is one of the largest online summit where we have about 60 to 63 different speakers live across 5 different tracks. So with that said, if you haven't registered yourself and help us advertise such amazing conference, we kindly request your backup to help us advertise this event. If you go to datadrivencommunity.com, as soon as you scan this, you will see there are feature data driven, which is a yearly summit, and there is cloud data driven, which is exactly why we are meeting today. Okay. So if you want to register, this is the QR code for feature data driven. You are free to copy this. And then remember, we are part of Microsoft community. Our code of conduct is titled to respect that, where respect, diversity, and inclusions take place. By the way, my name is Jean-Joseph. I am the founder and the secondary co-admin for this community. Within this community, I work very close with Wonen, and Wonen, I would say he's the head of this community. Even though for feature data driven, he's a little bit busy. He handed over to me, but Wonen is technically speaking the primary person for this community. Aside Wonen, we have Anna and Tipti that helping us. We used to have Oyela. She used to be an amazing person, but she gets a bit busy. She's not supporting us, but I'm pretty sure when she's free, she will be back and support us. So, as I said, my name is Jean Joseph. If you want to connect with me, feel free to scan this. I'm a former Microsoft technical trainer, and my background is mainly on data and AI. That's a little bit about me. I am also a former of Microsoft MVP. I've been in IT for about 23 years so far, and I built this community just to give it back because coming to America, my entire education used to be in French or Creole. The community helped me build that, and here I am now to support and give back. So, in in a nutshell, we are for that maintaining this community. And I would like to remind you about a couple event. I already spoke about feature data driven, which is our internal one. If you haven't registered yet for Visual Studio Live, first, we have a tons of SQL Saturday, and I explicitly mentioned Boston, but there's a tons of other SQL Saturday. If you go to sqlsaturday.com, I highly suggest you to go and register. I will also share the event with you. We have a Live 360, we have Ignite, Microsoft Ignite coming up. I highly suggest you, for example, to go and save your spot. So with that, we would like to congratulate you for sharing your time with us. It is a pleasure to have you all, especially our speaker, which is one of the speakers we all learn. We all love to learn from, and he knows his stuff. He blogs, he speaks, and in every single event I had a chance to go and talk to, I always have a chance to meet Dennis in person. Dennis, it is an honor to have you today. Feel free, for example, to share your screen, introduce yourself, and start with the presentation. Thank you.
Thank you very much, John. So, Thank you very much, everyone, for attending this session. Today we'll talk about Fabric Database and AI. Using vector search in Fabric Database for AI architectures. Both are very new features, very recent features in Microsoft Fabric. The Fabric Database are a new area in Microsoft Fabric and the capability of making vector search inside the database and using this for AI architectures. So this is me. My name is Dennis. I work at Onyx Data. I'm a former data platform MVP, trainer with some Microsoft certifications, and I live in Malta. I'm the leader of the Malta Data Platform User Group. You can see on the right side my contacts. It will be a pleasure to stay in touch, to connect in social media and stay in touch. I always publish content on LinkedIn, YouTube, and you can talk to me, ask any questions, and so. Let's start talking about Fabric Database, which is one very recent new feature. What are the Fabric Database? Fabric Database basically are Azure SQL inside Fabric, and there is a feature parity with Azure SQL. This means what Azure SQL has, the Fabric Database have. When we implement Azure SQL, we need to make some plans in relation to the implementation in Azure. For example, what service level will we use? How we will configure the service, the security features we will use, and so on. Fabric reduces these tasks even more to a level that we were not thinking that it was possible. By using Fabric Database, the tasks that we had to do to implement Azure SQL are even easier by using Fabric Databases. So, when we implement a Fabric Database, this is what we see inside Microsoft Fabric. For example, we see an object called SQL Database, and we see an endpoint called SQL Analytics Endpoint. And we also see a default semantic model. Many objects have a default semantic model linked to the object. The SQL database also has a default semantic model linked to the object. So we have the SQL database, the default semantic model, and the SQL endpoint. This is very interesting because in this case, this means that we can access the database through the SQL database or through the SQL Analytics endpoint. What would be the difference between accessing a database through SQL database or SQL Analytics endpoint? Is there a difference? That's the point. This is the internals of the architecture of the Fabric database. We don't need to, let's say, touch anything of this. But it's interesting to know that this is what's happening internally when we create a Fabric database inside Microsoft Fabric. What's happened? When we create a Fabric database, when we ask Fabric to create a Fabric database, the database is actually created inside Microsoft Azure. The database is, in fact, an Azure SQL. It is an Azure SQL. The Fabric database is an Azure SQL. All this drawing that you see here on Azure infrastructure is how the Azure SQL infrastructure works inside Azure. And everything is done for this. But not only this. Fabric also establishes a mirroring process between the Azure SQL we just created to Microsoft Fabric. So we have the Azure SQL as a production database, and we have a mirror of the Azure SQL in Microsoft Fabric. We have the production database, and we have a mirror of the production database. So this is the structure which is created for us by Microsoft Fabric when we create a Fabric database. This explains a bit the previous image. In the previous image, I was highlighting a bit, but not that much, that we have 2 points of connection. We can choose where we will connect, if we will connect to the SQL database or if we will connect to the SQL Analytics endpoint. And this is an important choice. In the past, we would have to do a lot of work to get these 2 options. Now in Fabric builds these 2 options to us and just give to us. We just need to choose the right place to use each one. What's the difference? The difference is that the SQL database is the production database. It's intended to be used by production applications. Is an Azure SQL where we can read and write information. Is intended to be used by production applications, writing data during the production work of the company. On the other hand, the SQL Analytics endpoint is the result of the mirroring of this Azure SQL to inside Microsoft Fabric. So this Azure SQL is mirrored to inside Microsoft Fabric and generates the SQL Analytics endpoint. This endpoint is read-only. It's a mirror of the production database, so we can't make any change in the analytical endpoint, in the SQL Analytics endpoint. In this way, this endpoint, the SQL Analytics endpoint, it is great to be used as a source for our analytical applications, for our semantic models, our reports, and so on. So the ideal is to use the SQL Analytics endpoint from the SQL database as a source of data to our analytical application. Why? Because by using the mirroring as a source for our analytical application, we will be preventing to put workloads over production. We will leave the production database to be used for production. All the resources of the production database will be dedicated to production, while the mirror will be used for analytics, for BI analysis. In other words, Fabric is giving to us out of the box a good practice to use a SQL database. It's giving to us out of the box a SQL endpoint, SQL database, where we can connect our production applications, and the SQL Analytics endpoint, where we can connect our BI applications, our semantic models, reports, and so on. If we mix, we will be affecting the production work. This is not a good practice. So Fabric is giving us a good practice built out of the box. And this is great. This is great. So why Fabric database? To reduce the management trouble of cloud infrastructure. So the amount of infrastructure that we need to manage in the cloud is way lower by using the Fabric database. The Azure SQL was already, let's consider it easy. Fabric databases are even easier. So it reduces any management over the cloud infrastructure. ideal for low-code environments. So if you are already using an application built with Power Apps, built with a low-code environment, and you would like something as easy as the low-code environment, Fabric database is perfect for you. And it provides for us a preview isolation between the production and the analytics environment. There is isolation I was just explaining. So it provides us this pre-built isolation. So these are very good reasons to use Fabric database. You will only would like to go to Azure SQL if you really want to have a fine-tuning control over the details of the SaaS level that you are implementing, the security details, and so on. If this is not so critical for you, the Fabric database are perfect for you. And besides that, before the Fabric database arrived into Fabric, we had the capability to create a mirror from Azure SQL. We could provision the Azure SQL, a SQL database in Azure SQL, and we could mirror that SQL database to Fabric. We still can do that. We can get a mirror from an Azure SQL database. We still can do that. What's the difference from this and to a Fabric database? From this and Fabric database. The difference is the amount of work we will have. Fabric database does all this for us. When we create a Fabric database, it provisions the Azure SQL, mirrors the Azure SQL for us into Fabric without giving us any trouble. Uh, while if we decide to do this manually, we need to make the provision on Azure and establish the mirroring from Azure to Fabric. So we have many steps to make. It's a decision about how much of control we would like to have on fine-tuning of the configuration, or if a simple database is enough and we just want it to work. So this is the pre-built analytics isolation. I was talking exactly what I was explaining. That we have an endpoint used for production and we have an endpoint used for analytics. And I was talking about mirroring, the comparison with mirroring. With Fabric database, the mirroring is managed for us. Fabric managed the mirroring for us. If we decide to implement an Azure SQL and then mirror the Azure SQL, then we need to make the provisioning and the mirroring. We will be managing this. It's about who manages these steps in the infrastructure of the environment. One interesting detail for who knows more details about Azure SQL is that Azure SQL only supports mirroring above the level S3. And Fabric database implements mirroring by default. Is an Azure SQL mirrored to Fabric. This means that the minimum level, when I say level, you can understand the minimum price level of a Fabric database is the equivalent to the S3 in Azure SQL. This is around $200 a month, $100 a month, more or less. Something like that. Something like that. This is the minimum level for a Fabric database because it requires the mirroring. It doesn't exist without the mirroring. Who knows Azure SQL in detail knows that there are access levels in Azure SQL which goes down to $5 a month. If we're making very small tests and don't require many features, you can use some levels of Azure SQL for $5 a month. but in mirroring to Fabric, for example. So this is one detail to consider in relation to cost when deciding about using Fabric database or Azure Secure. This is an interesting detail to note. Now, let's talk about vector search and AI chat solutions. Why? It seems a so different subject. It's because almost at the same time, the Fabric database were being announced inside Microsoft Fabric. A new feature was being announced in Azure SQL and, as a consequence, available in Fabric database as well. Is the feature called vector search. Support for vectors. To understand what is a vector search, we need to talk a bit about AI architecture. There is an architecture, a very used architecture in AI environment called RAG architecture. The idea of the RAG architecture is to solve a very common problem. How will I have a chatbot, for example, an LLM model, answering questions about my company's private information? How can I do that? There are some ways for to index this information, make this information accessible to the chatbot in a private way. And the vector search is in the core of this architecture. So the RAG architecture is the architecture that we started using when we started this scenario uh, to feed the models, the AI models, with private information from the company. Then it's interesting to understand what is embedding. Embedding is a specific type of vector. The name vector is a mathematical representation, is a mathematical element, a mathematical representation. Embedding is a specific type of vector. Embedding is a type of vector used by natural language processing and for search of content. The idea of an embedding is to make an extremely powerful search of content inside our environment. This is the idea of embedding. But when we are talking in the context of AI, usually vector and embedding are used as synonyms. There are very few situations when vector and embedding are not actually used as synonyms of one for another. Let's see an example. Here we have an image of a math vector. A vector is this, a set of numeric values, a specific set of numeric values. And an embedding means to use a vector to represent the meaning of a word. So this set of numbers are representing the meaning of this word. What exactly each number represents depends. To create the embedding, we also use an AI model. An AI model to make the creation of the embeddings. And depending on the model, the meaning, actual meaning of each one of these numbers is different. So we usually don't go so deep on the meaning of each one of the numbers. What's important is how close the numbers are one from another. because the algorithms, the models made to create the embedding, are made to understand the meaning of the words and generate the vectors according to the meaning. Mind this example related to queen and king, woman and man. Woman and man are not the same, but they are similar. So you can see the distance between the vectors woman and man is relatively small. For example, zero point 0.2 to zero point 0.4 is a small difference considering the distance from zero point 0.2 to zero point 0.7 or zero point 0.9. So the distance between human and man is small because they are close related to each other. The distance between queen and king is also small, only zero point 0.2 in difference because they are related to each other. So we can note by observing the vector, by calculating the vector, what is related to which words, which sentence are related to each other in relation to the meaning of the sentence. It's not anymore a text search, a match of the text. It's about a search for the meaning of the words. And look for the first part of the vector. Man and king have the same value on the first part, zero point 0.5. Why? Because a king is a man. So they are extremely close because a man is a king. A king is a man. A king needs to be a man. And the same happens with woman and queen. Woman and queen is zero point 0.3 because a queen is a woman. So we have these relations of meaning in the vector. That's how the embedding works. And this brings the idea of making search with this information. Let's understand step by step how the RAG architecture works in Azure. Inside Azure, we provision a service called Azure OpenAI. Everyone thinks that that service that we provide, many people think that service we provide, Azure OpenAI, that is the model. No, no. That service we provide, Azure OpenAI, contains deployments of models. Yes, each model can make one processing for us, but the service itself makes much more than only uh, processing the model. Let's see this step by step considering a RAG architecture. Let's consider that we have a chatbot or an app that gets an input from a user. The user makes a question, and we send this question to Azure OpenAI, to the Azure OpenAI service. So we are talking about um, the user question is sent to the service. This area here is intended to represent the service. Everything here is inside the service Azure OpenAI, and the user sends a question. This question is received by Azure OpenAI. Is received by the model? No. Many people think, oh, we are sending a question to the model. No, it's not the model who receives the question, not immediately. It's like a coordinator, and then many steps will be taken. Azure OpenAI create embeddings and vectors for the question. So the user sent a question. So Azure OpenAI will get the question the user made and create a series of embeddings for this question. I've created a vector for this question, create an embedding for this question. In this way, we have a mass representation of the meaning the user is looking for. The user is looking for a specific meaning, and we have a mathematical representation of this meaning. How this mathematical representation will help us during this process, of to solve the user question. The idea is that previous to this process being executed, we already created embeddings for all the company information, for all the company documents. Imagine PDF, Word documents, many types of documents. We pass them by a model and we create embeddings for all these documents and we store these embeddings somewhere. Somewhere, usually is an Azure AI search. Then the Azure OpenAI will use the embedding of the question to search for related documents. So it transformed the question of the user in something with a mathematical meaning. And then we'll use a storage to make a calculation with this embedding and retrieve the documents which are closer to this question in relation to meaning, in relation to the meaning of the question. AI search is one very common feature we use to store these factors, these embeddings. But the title of this session and the content of this session is already giving a spoiler about what we are about to see, is that AI search is not the only one capable to store this kind of thing. AI search stores this kind of thing, the embedding for content which is non-relational, non-relational content, but in databases, in this case, in SQL database, now we can store vectors inside the database, in tables inside the database as well. We'll get that. But continuing the process, a search is made to locate the documents which are closest to the user question, closest in meaning to the user question. Once this search generates the related documents, the Azure OpenAI builds the prompt using the located documents. It means now the question the user made will be joined with the content of the documents which were found, and these will be sent to the model. So everyone thinks the communication is being done directly to the model. No. See, we have all this orchestration of steps to search the documents. And then the model, the Azure OpenAI, sends the prompt to the GPT model, and the model will provide the answers to the user. So, once the prompt is built, the question is sent to the model, to the GPT model, and the model will provide the answer to the user. Another interesting point and another interesting reason for this to work is that many people who heard about the models, you know that the models and what evolves in the models are the number of tokens the models support, the number of tokens per minute, and the number of tokens which are accepted on each question. And this is limited to a specific number of tokens. And you can interpret tokens more or less as a word or a letter, more or less, but it has more an internal mathematical meaning, but it's close to a word or a letter. So the model has a limitation on the number of tokens. So imagine if we hadn't this process. Could the model in some way analyze all the documents from your company to look for the information that you are asking about? No, that's not possible. You can't get all the documents, give to your model, and ask for an answer. The model doesn't accept all this volume of information. It's too much. So all the AI architectures use a process of search before it gets to the model. Carlos is asking the size of the embeddings. The size of the embeddings depends on the model that is creating the embedding, is used to create the embedding. I will talk about the size of the embeddings in a slide a bit forward. In a moment, I'll be talking about the size of the embedding. So, uh, so all the AI architectures needs to rely on some kind of search. The methods of search vary, and you may be hearing in LinkedIn, for example, many variations of from the RAG architecture. You may have faced many variations from the RAG architecture. Yes, there are many different variations which use different methods of search and so on. But in the core of these search methods is the vector search capabilities, the use of embeddings, the capability to transform a content in a mathematical meaning of this content and search related content according to the meaning. That's what vector search is. That's what embeddings are. So the model is there, the GPT model. So uh, I was about to mention some RAG limitations. Limitations related to RAG, once we understand this architecture, we can notice some limitations related to RAG. It's impossible to get all documents related to what the user is asking and give these documents to the model. It's not possible because the model doesn't support this amount of tokens. So what will happen? The question the user makes is transformed in an embedding, and the documents which are closest to the question will be delivered to the module. Is it possible that some important document to answer that question was left behind? Yes, it is possible. It is possible that some important document to answer the question is left behind. So the reg limitations, the reg is a document search. Is not a text search, but it's a document search. It's not a precise search. It's limited by prompt size. It lacks database level precision. For example, I faced some situations where the user who was asking for a chatbot for a web environment was was willing to ask things like how many orders the company X made during this month. This is not to be answered by a RAG architecture. This has other methods to be solved. It is not a RAG architecture which will solve that. There are other architectures to solve that. So the RAG architecture is for uh, non-relational data, unstructured data, and it lacks some database level precision. For database level precision, you have other kinds of architectures. And in fact, just to mention, Fabric released the data agents. I even have a video about data agents in my YouTube channel. The data agents are capable to make questions over your data. These will give a bit more of precision. But for unstructured data, RAG is the ideal when the data is not structured. So there is a lack of database level precision. For example, could you list the orders from customer XPTO? There is no way to be sure that all the orders will be listed. Could you list the sales from John? The same. Could you list the bicycle orders? The same. There is no way to have a database level precision in RAG architecture. This is for other kinds of architecture, such as the data agents in Fabric. Vector search in relational database. The vector search in relational database brings the power of the search for a meaning of a question, for a natural language processing question, to a relational database. So it joins a bit of a powerful search for content, for the meaning of something, with the precision of a database, a relational database system. So possibilities. We can use this feature as part of a RAG architecture. Instead of using the AI search as the storage for a RAG architecture, we can use a Fabric database as a storage for an AI architecture. It's a different method to implement RAG. Workaround for database precision answers so we can reach a better database level precision answers in some situations. It's more advanced than a regular text search. SQL Server built the full text search. SQL Server has the full text search. But this, we are talking about a search by meaning, not a search by text or text resemblance, but by meaning. So we're talking about a natural language text search. For example, I'm looking to buy a comfy red sofa. If I make a text search, this will bring these two products, for example. But if I make a vector search according to the similarity of the meaning, there are two other products which can be displayed to the user and may be interested to the user. The user may be interested in this additional product. So it's more advanced than a text search. So how the vector search works? Okay, so we saw what the vector search is, what the embeddings are, but what exactly are the main new features which are present in Fabric database related to vector search? What we have is the vector data type. We have a data type inside the database of type vector. So we can store a vector in a column of a table, for example. So we can generate embeddings for the record and store these in a column of the table. And we have functions to make specific calculations with the vector. Vector distance is one of the most important ones, but there are other functions as well, which allow us to play with the calculation method in relation to the distance of the vectors. So, steps required. So we have the functions and we have the data type. What else do we need? We need to generate the embeddings for the records. Imagine an example. Imagine that I have a table of Walmart products. So I can create a new field in the table, and this new field will be a field of vector type. Okay, but the field will be empty. In this, what you need to do is to generate embeddings and fill these embeddings into this new field. Okay. Then, when the user comes with a question, when the user wants to make a natural language question, I will need to generate the embedding for the question as well. So I need to generate the embeddings for the existing records and the embeddings for the question. Then, uh, after generating embeddings for the question, I make the search. I use a function like vector distance to search the records by resemblance with the question the user made, according to the meaning of the question and meaning of the record. So make a search by vector distance by looking for the meaning the user is searching. And this will give me an answer. This will give me a set of records which are the closest one to the question that the user made. After that, I can decide. In some architectures, this may be enough. Maybe this will be enough to some objectives I may have. But I can also make additional steps if I would like so. I can get the result of this search, the vector distance search, and build a prompt to send this prompt as a natural language question to a model. So I execute a natural language processing question in an OpenAI model, for example, and the OpenAI model receives the user question and receives the set of products which are closest in meaning to the user question. Then it prepares a natural language answer to the user and decides which products are the products which are uh, most probable to be to interest the user. And one secret in all these steps, in all these additional steps which I mentioned, one critical secret is this external stop procedure called SP invoke external REST endpoint. This stop procedure is capable to call external APIs from TSQL. This means that from a TSQL language, I can call any external API. And this includes APIs to generate embeddings and APIs to ask questions to an OpenAI model. So I can make calls to external APIs using this stop procedure. How it works? It requires a credential object. Of course, imagine that I'm making a question, I'm sending an API call to an Azure OpenAI SaaS. I need to have the key of the SaaS, the API key of the SaaS, and I need to store this API key in the Fabric database as a credential object. Then I can make a call to Azure OpenAI SaaS. I can call to generate embeddings, or I can call to make a question to a GPT model. A limitation of this store procedure is that it only calls Azure URLs. It's a security limitation. It doesn't allow you to call anything outside Azure. But there is a workaround to this limitation, a workaround that allow you to call other APIs without compromise the security. How? You can use the API management in Azure. In Azure, you can provision an API server and you can hash the APIs you would like to call in the API server. This procedure is capable to call the API server, and the API server will work like a proxy to your APIs. Will deliver the message to your API and deliver the result back to you. So this is a method to call any API outside Azure environment. It's just a detail. I mentioned as a detail is not the main focus of the session now. Okay. Creating the vector field. This is an example of the creation of a vector field. Alter table, Walmart product details, add product description vector, vector 1536. 1536 is the size of the vector, but it's a very specific size. Yes. The size of the vector depends on the embedding algorithm. Each algorithm that we decide to use to generate the vector provides a different size. But the current maximum size of the vector field in this feature is 1998. It doesn't support anything above this size. So we can see some algorithms to generate embeddings, and we can see that there are algorithms capable to generate embeddings way bigger than 1998. So, are we forbidden to use this algorithm, for example? No, not exactly. There are some API tweaks that we can use a more powerful algorithm like the test embedding 3 lash to use this algorithm to generate the vector. The trick is to pass a parameter in the API call which limits the size of the vector to the size we would like, for example, 1998. So we pass a parameter in the API call limiting the size of the vector. Wouldn't it make it the same as a smaller and previous version algorithm? No, because the algorithm, what makes the algorithm better is not only the size, is the way it processes the content. So even if we ask a vector a bit smaller, the way it processes the content is still better than previous algorithms. The credential. The creation of the credential to access the OpenAI service in Azure will create a database scoped credential. One thing which is new is the identity. The word that we use for the identity, we use the word HTTP endpoint headers. This means that we want this credential to be included as the header of an API call. You may note this credential is in the JSON format. In the JSON format, I'm putting a pair of key and value to include my API key. The secret is my API key in JSON format, and this will be included as part of the header of an API call. In this way, we manage the credential to call the external API. And get embedding is stop procedure. Stop procedure? What do I mean about the stop procedure? What I mean is that we already mentioned how I need to get embedding in many different ways. I need to get embedding to fill the records, fill each record with the embedding related to the record. And I also need to get the embedding for each question the user makes. And the process to make the API call is not that simple. It's not that, let's say, easy. So the better way is to create a stop procedure to make this embedding call. So this is the get embedding stop procedure, the get embedding. It receives as parameter the name of the model, the question the user made, not only the question the user made, the input text which will be used to generate the embedding. And then will result on the embedding as the output. So one of the main points of the procedure is the SP invoke external REST endpoint to make the call to the API. Then it defines the URL. The URL is defined one line before here. And the URL is a special construction with the URL of the OpenAI service. I said before, the OpenAI service in Azure has deployed models inside the OpenAI service. And these models have names. I need to know the name of the model to include here in the URL. And the beginning of the URL is the URL of the service itself, the OpenAI service. Then I have the payload. The payload is a construction with a JSON object function. I'm getting the input text and transforming in JSON to be the payload for an API call. So the JSON functions become very important in these situations. So the input text to generate embedding. Then we process the output. The procedure invoke external REST endpoint gives us an output which we'll need to interpret and process. The processing of the output varies according to the API we're calling. And sometimes it varies even according to the way we are calling the API. The way the API will send us the result. So this is the result of some experiments I did, and this is the processing to extract the embeddings from the JSON result returned by the API. So I extract the embeddings and I return the embedding as a vector, making a cast as a vector. Then, once I have this stop procedure ready, I need to build the embeddings for all the records. Yes, build the embeddings for all the records. Here I'm building for 30,000 records. I need to process the records one by one, one by one. Luckily, in my table, product details, Walmart product details, the ideas are sequential. So I'm using a counter variable to get record by record. And for each one of the records, I make a call for the get embedding procedure, asking to get the embedding for the text variable. Text variable is the concatenation of the product name and product description. Concatenating the product name and product description, generating the text passing to the get embedding, and then updating the record. So a script like this updates the records in our tables. One table in this case. Then, to get the actual result for a search. So here I have what I'm searching, the question sent by the user. Help me to plan a high school graduation party. Okay, let's plan on a party. Then I need to generate the vector for the question. I will use the get embedding to generate the vector for the question. And the search vector is an output variable, the vector generated for the question. Then I'll make a query in the table, Walmart product details. And this query will bring the vector distance. The vector distance between the field where I store the vector for the record and the vector of the question of the user. So I'm comparing the question of the user with the vector for each record. So I'm making this comparison between the question and the vector of the record. Uh, Cosine is the method of comparison. There are other methods. There are other reasons to use other methods. This is the most common one. I will not get so deep into details. But then the vector distance generates a numeric value as a distance. How close or how far the record is to the question in relation to meaning. How close or how far. So I ask to order by the distance and get the top 10. In this way, I'm getting the top 10 products which are closest to the meaning of preparing a high school graduation party. I'm getting the closest records to this. Let's see this working. In Microsoft Fabric, I have here a Fabric database vector sample with the table Walmart product detail. The table is already built with the field, the vector field. Product description vector, it's already there. And to illustrate what I mentioned about the Fabric databases, let it lower just a moment. Let me remember, be back to the workspace. Here is the Fabric database, the SQL database, let's say endpoint, and the SQL Analytics endpoint of a single Fabric database. Okay, I can connect to this Fabric database using SSMS. So to connect to SSMS, I just need to get the connection string of the database. I can go to settings, connection strings, and get the server name. I need to use the server name and the database name in the connection string to make a connection through SSMS. So here I have the connection. Each one of the scripts I illustrated, I have here, and these scripts are shared in my GitHub repository. So I have the script to create a vector field. I have the script to create a credential. The script to create the get embedding procedure, which is a reusable script that you can use in your environment. The script to build the embeddings for one table, my example is the Walmart table, you need to adapt to your environment. And here, the search. The search for the natural language question. Help me plan a high school graduation party. So it's making exactly what I explained. It's generating the embedding for the question and making a query in the database according to the vector distance. So I execute this. Is making an API call to generate the embedding and then comparing the embedding with the value of the vector field. And this is what was located. Graduation yellow hanging motorboats, party creations, beverage napkins, party creations, happy tree, and so on. So many products related to the meaning of the questions were returned. Uh, green football, 7 plates. There is nothing here related to high school or pie, but these are plates and they may be needed in a pie. Chairs that may be needed in a pie. So there are many products which are related meaning to the question. So what we are seeing in this example is the power of searching a database table by the meaning of the content and not only a text search or a text similarity search, but the meaning of the content. And it was fast. It was relatively fast, considering the number of products I have here. We can change this, for example. Let me change the question. I would like to prepare a barbecue at home. So it completely changed the question. Check the products it's giving to me. A grill, a marinade sauce for barbecues, digital electric, something I'm not seeing the full name, but we can see that we have products related to the meaning that I'm looking, to the meaning of preparing a barbecue at home. Okay, we can go one step further. We can move one step further. Here I have another step procedure to make a call to the GPT model to get the results from the search and make a call to the GPT model. This second step procedure is summarizing all the tasks. So the same question, help me plan a high school graduation party. But this time I will call the step procedure get an answer. This step procedure get answer internally will generate the embedding for this question and will send will make the search in the database for the products closest to the meaning of this question. We'll use the products to build a prompt and send to the GPT model. So check. It's calling the generation of the embeddings. It's playing with JSON functions to generating a payload with the content of the products and a prompt about how the question needs to be answered. And then it's processing the answer. So let's run. So it's giving me the answers. I asked the GPT model to provide me an answer, provide me the product selected. I had 10 products, but the GPT model selected 3. The GPT model is telling me these 3 products are the main products your customer may be interested on. These 3 products. And I asked the GPT model to tell me how it reached this result. So let me copy this question. So this is the answer the GPT generated for the user. We can deliver this answer to the end user. For your high school graduation party, you can create a festive atmosphere by decorating the venue with graduation yellow hanging mortarboard mobile ready party wall decorations. Head cap. The product ID 2903. It is being recorded. It is being recorded. Add a personalized touch by using the Deadpool Grad Cap Castle and Topper product ID 19381. So we got a personalized natural language answer to the user. The list of products the user should be interested on, and the reasoning how the model reached this result. What the model did to generate this result. And the model is explaining. I selected the decorations and accessories which are suitable for a high school graduation party, and then explaining the product selected. So you may notice there are many possibilities that we can generate here. Um, it doesn't mean I need to make execute all these steps. In some situations, in many situations, the simple search may be enough for some solutions. In other situations, I would like to get the result of this search and send this result to the GPT model. I may send this result to the GPT model using T-SQL like I did now. I just did. Or maybe I would like to use an application. The application would get the result of the vector search and the application would send to the GPT model is an option. There are many different possible architectures to be built with this feature. The point is, we are going to another level. We were working with text search, and now in the era of AI, we are working with search by the meaning of the information. We transform the information in a mathematical representation and we search by the meaning of the information. This is the vector search implemented inside Fabric databases. Okay, so that's it. Some reference files from this presentation in my GitHub. The Wikipedia, there is an walkthrough using Wikipedia example, and there is an walkthrough using the Walmart example. They are not precisely the same that I presented, but you can follow some steps and remind some details that I showed and join the pieces. So these are some reference about what we saw today. And here my contacts again. And again, it will be a pleasure to stay in touch in social media, in LinkedIn, YouTube. It will be a pleasure to stay in touch. Thank you very much for attending this session.
What an excellent presentation. Thank you so much, Dennis. You know, that's exactly who you are. Take your time, demystify the core concepts. You did an amazing job. Thank you so much. Tim, if you have a question, feel free to ask. Otherwise, it was a pleasure to have you. Don't forget to sign up for our upcoming webinar and enjoy the rest of your week. And Dennis, I hope we have you next year. Thank you for your support.
Thank you very much. My support will continue. For sure. I will be available. And if anyone has any questions about what we saw today, any additional questions? The question about the size of the embeddings, I explained it. It depends on the model and we can work around the limitations. Okay.
You didn't leave
Thank you
room.
for the presence, Julia.
Thank you.
Hmm?
Thank you, everyone. It was a pleasure to have all of you. See you next time. Don't forget to register for Feature Data Driven. And there's a couple other events. I have put the link on the chat. I highly suggest you to go and register and join us. Enjoy the rest of your week. Thank you. Bye-bye.